In the last segment, we discussed about what a system of forces is, and then we also give a hint that in this segment we are going to talk about like what are the steps, what are the tools, what are the techniques one should use to simplify a system of complicated forces, so that finally we will reach at the simplest of the resultants. So that is basically the idea of this segment. And to start with, what I will do is I will list out some very trivial steps which one must always do to simplify some obvious force conditions, and then we will get into some slightly less obvious or a trickier substitution or replacement which will be very helpful in simplifying a complicated system. Coming to the trivial ones, the first thing is, whenever you see a lot of say concurrent forces, for example F1, F2, so like that, you have a lot of concurrent forces. Similarly F4, say F4, like that, and many more maybe, but they are all concurrent at some point of concurrency. Okay, so some are pushing force and some are pulling force, but the common thing is that they all pass through the same point in space. Now, if that is so, then you can, this whole thing will be equivalent to a single force in some direction. Okay, so at that particular point, so I will just reverse the color orders. At that particular point, say the point is say A, here it is A. Okay, so all these forces can be considered equivalent to this force. Now, its direction, its magnitude will be dependent on the values, the direction and magnitude of all these forces, but in conclusion some force will come in some direction. So that is the idea. Okay. So just a vector addition will tell us that. Okay. Now the second trivial thing is about the transmissibility of a force. Okay. Now suppose it is the line of action of a force then for all our considerations, because we are dealing with the effect that whether a rigid body is stationary or basically its dynamics, whether it is stationary or moving with a constant acceleration does not matter. We are talking about the dynamics. So when we are studying about dynamics of rigid body, forces are transmissible. Okay. That means if the force is F, on this line of action you can move the force without changing in its effect, because we are not under this part, we are not considering any flexible body. Now coming to the third of the trivial tricks, it is like the couple moment is free, or should I write a free vector? Okay, I will write C is a free vector. Okay, so we had seen what exactly it means, but this concept should always be used, and it's very obvious that you can move it anywhere without changing the line of action of this force, okay. Because again, as I just mentioned, we are always concerned with the dynamics, and for dynamics you just can by keeping the line of action parallel, you can move it anywhere in space. So it's a free vector. So these are the three most trivial things which first you should think about if you see a problem where with a system of many forces. Now coming to the less obvious and a trickier situation. Now that I'll phrase it like this. Say I'll give a name like fourth in that sequence. Can you translate a force to a position such that its line of action moves parallelly moves parallel to its original position. Okay. So translate a force. So what exactly does it mean? That means suppose you have a force something like that, F, and let me also draw a set of axes, okay, x, y and z. Now force is hovering somewhere like that, and now you want, and then let me show also a point where it is being applied, say A, and you are trying to transfer this force parallelly. See, the line of action moves parallel to its original position. So its original position is like this, and you will move it somewhere to say point B here, and you want the force to come here. Okay. Now what? But you want the system to remain unaffected. Okay. You also want to move F, but you want that the system should not know that you have actually moved it. Okay. Then what you should do? The point is, as you are moving it, you have to compensate this with addition of, so addition of a moment, or I'll say a couple moment, sorry, couple moment. Now whenever you move like that, you have to compensate this movement by a couple moment. Now what exactly do I mean by that? Let's see. Suppose you have this plane, how do I, okay, let's say, suppose you have this plane. I am trying to draw a bigger picture. Okay. So now this is the plane on which you have the force. Okay. Say like this. this was the force. See, in the previous case, I mean, I didn't draw any plane as such, but you could have thought of this movement by keeping this line of action parallel. You can think of a plane which contains both these vectors, okay, through these two parallel lines, which are the line of action original and the new one. You can always think of a plane, and in this diagram now, sorry, I am drawing the plane first, okay. That's the only change. Otherwise, there also you could have imagined about this plane, because now we will talk with reference to this plane, so I have drawn it first. And let me draw also the say maybe the axis like that somewhere, say x, y and z. Okay. Now f is somewhere here, and you want to move it to a location, say here, say it's called A. Now the concept is, you do one thing, that let's add an equal and opposite vector at the same point A, so like that, and which is equal to f. So let this be called f, this is minus f. Okay. By adding these two vectors, we are not changing the system at all, because they are cancelling each other completely. That's the main idea. Okay. So whatever point you want this force to be moved to, so there you think of adding two equal and opposite forces which will cancel each other. Then what? Then think that consider now this force and this force. Are they not forming a couple moment? They are forming a couple moment, right? So that means we can consider these three forces now as a couple moment of, say, this type, which will be, you know, and then its magnitude will be, say, I'll write it here. C magnitude will be how much? F times this distance d. So if F magnitude is this, d is the distance between them, say let d be this distance through which you moved that line of action parallelly. So now this couple moment arrow, I have tried to draw it perpendicular to this plane basically. Okay. So this angle is 90 degree. Okay. Now, so then you can think that now these two forces have been replaced with this couple moment, and you are left with this force alone. So can I do one thing? I'll just copy this whole thing. Sorry. And move it to a bit here. Okay. And okay. Can I just okay, now I have some space there. So what I wanted to tell is, now does it not look like something? Again, I am trying to draw the same plane, sorry, like that, and this force have been replaced by this, and then now only this force remains, and I'll say that the point A here lies like this, and the force now is here F, and there is a couple moment like that. Okay, so couple moment like this, which is perpendicular to this plane. And let me also, for completeness, I'll just draw this line. Okay. Okay. So they are equivalent. I'll say that these two conditions are equivalent. So this should be clearly understood that when you move a force, so you see the first what was the condition and now what we have got. First F vector was only there. Now we have moved that F vector. So let me say the initial point was say here. Let me suppose this initial point was B. Initially the vector was passing through B, and now if I want to show that B, maybe it is somewhere here still. Okay, and from B you have moved the force to the point F by keeping the line of action parallel to the original position, and in doing so you have to add this compensatory couple. Okay, you have to add this compensatory couple so that these two systems will be equivalent. Okay, means here this I have drawn this just to show, otherwise this was not there in the situation, right? This what should I do? You understand what I mean. I mean, in the process of derivation I have drawn it, but the equivalence is between this force at B is equivalent to the same force being shifted to A plus a couple moment acting like that. So that means I'll say a force when moved, and when I say moved, you understand what I mean. So the line of action, it is moved parallelly to the line of action, is equal to the force plus a moment. Okay, so that's the basic point which I wanted to make. Okay, now, and then this will be quite useful. Here I want to make some point. See, some students feel comfortable in another interpretation of this result, and that is they say that okay, there was a force, now it is a point which I am interested in. So about this point, this force had anyway a moment in the original case, and now when I shifted this force to this location, that moment has just vanished, and that is why I am adding this. So that is another representation or interpretation of this full derivation and discussion. Okay. So again, that is like a compensatory, because you have moved it here. So the moment which was caused by this F at A, so now it has gone, so you have to add it somehow. So that is what you have done by adding it. And but there is a slight you have to be very careful if you are following this logic, the second one, whatever I am telling, you have to be very careful in the sense that whenever they say that okay, they replaced with the moment about A of the force F, they tend to miss the point that this couple moment now is a free couple moment. You can move it anywhere. But if you think that you have replaced with the moment of the force F with A, about A, somehow they tend to feel that the moment is only about A, you can't move, because the normal moment is not what you are getting here. You are getting a couple moment, right? Because see, this minus F and this F is constituting a couple moment, and that is free. So in a complex situation, when you have to shift it somewhere for compensating it or cancelling it with some other couple, you can do that effortlessly if you think that it's a couple moment. So please, whatever is comfortable, you interpret in that way, but please remember that this moment which you are now getting is a couple moment, and it's free to move anywhere. So that's one point. Then yeah, what else? Is the reverse possible? For example, see here, you converted a force to a force plus moment. Now can you do the opposite? That means if you have a force plus a moment, can you convert that into a single force? Okay, is the reverse possible? Let's see. So in this case, we have something like this. Again, I'll draw a plane. Okay. So say this is a plane. Now there is a force, say here, and there is a couple moment. Say there is a couple moment that and which is perpendicular to this. For example, like this. Okay. So okay. So there is a couple moment. That means the couple which causes this lies on this plane. So that's the requirement. Let me draw even that. Maybe like this. Okay. So there is a, so how will it happen? Yeah. So this may be a force, and this is another. So maybe this is Q and minus Q, and they combinedly cause this couple moment to exist. Okay, let me slightly make it look good. Yeah, okay. And for completeness, I always like to draw the axis. Okay. Now, so this is x, this is y, this is z. Okay. So then, can we do something that this couple moment will just vanish and only the force will remain? So that's quite possible, because you saw in just a few minutes back that by moving this force we can create a couple moment, or yeah, so you can interpret it in both way. When you move the force, you have to add an compensatory couple moment. This is one phrase which you can think of. Other way to look at this is, by moving this F, you are actually creating a couple moment. Now that induced couple moment, if that cancels out this, then you are done, right? So for example, suppose you move this force to this point. So yeah, so let's see, if I move this force to say this point here. So this point is say A. So what I will do, I'll just follow the initial method so that you will get acquainted with the idea. I'll just draw it here because I need some space there. Okay, now I'll just shift this here. Okay, and I will add both F and minus F. This is not parallel, please forgive me for that, and I'll again try to draw. So let's, yeah, so F and minus F. Okay, so this is F and this is minus F I have added. So by adding that, I am not changing the system at all, but then what is happening, this F and this minus F constitute a couple, and which is actually acting in the opposite direction. That is, say I'll use say this one in the opposite direction, and it's I'll just represent this here. Let me draw it dotted to just show that it is behind this up to this point, and from here, yeah, solid lines and like that. Okay, now this couple, I'll say C2, I'll call it C1. Now this C2, which is coming up because we have moved F from the point B to point A. So this has now come up. This is the compensatory couple moment which has come up. Now if this is just, if C2 that has come up is minus of C1, then what happens? They will just cancel each other out because they are free vectors, right? They will just cancel by moving wherever you want. They will cancel each other, and then you are left with only this. So again I'll do the same thing. I'll try to draw this. Okay, so here, and you just have now the point A here, okay, and the force F, that's it. Now, okay, I'll just try to draw the axis so that you will feel that they are the same thing. Okay. Okay. So X of Y and Z. Now that means these two are equivalent. Initial case, there was a force, there is a couple moment C1. Final case, that force which was initially at B has been shifted now, and that's it. And then this C1 which was initially there is gone, and you are left with only a force. So you have converted a force plus a moment. When I am saying moment, I am meaning a couple moment. Okay, so that has been converted into a force. Is that fine? So this skill of moving a force and then by compensating it, this movement with a couple moment, or the vice versa, substituting a couple plus force system with just a force system. Now this skill you should acquire and then get comfortable with it by practicing on actually many problems. Okay, once you do that, this trick will be used multiple times in many complex situations where we will have systems with many forces and many couple moments. Okay, once you have understood it, we are ready to move and understand things where first we will take up some special cases of systems, and then we will go to the most generalized system, and that will be beautiful.